In this video, we're going to talk more about functions, in particular linear functions, as well as linear equations, but only using two variables, x and y. We're going to start with what a linear equation actually is by definition, and talk about something called the standard form for a linear equation. So our definition, we're going to let a, b, and c be real numbers. Such that a and b are not both 0. It's okay if either a or b is 0 as long as they're not both equal to 0. Then a linear equation in x and y is an equation that can be written in the form ax plus by equals c, and that is called the standard form. Now, usually, even though this definition only says a, b, and c are real numbers, usually our a, b, and c are integers, so they're whole numbers, positive or negative. We're going to start by graphing some linear equations, which will show us exactly why they're called linear. So let's graph. First one we're going to graph is 4x plus 2y equals 2. And we want to graph this. And there's a lot of different ways to do so. I'm going to graph it by solving for y and then creating a table of points that I can plot and then connect. So if I solve this for y, I can subtract the 4x to the other side. And then I can divide everything by 2. So I'm going to have 2 divided by 2, which is 1, and the 4 divided by 2 is 2. So I get y equals 1 minus 2x. Now I'm going to make a table of points, and it doesn't need to be very big, because when you're working with a linear equation, the graph is going to be a line. In order to make a straight line, you only need 2 points, and then you just connect the dots, and you have your straight line. So to make my table of points, I'm just going to pick some values for x, plug them in to get y, and then I'm going to graph those points. You should pick easy values for x, if at all possible. So I'm going to choose 0 and 1, because those are really easy to plug in. When I plug a 0 in, I'm going to get 1 minus a 2 times 0, so that's just 1. And when I plug 1 in, I get 1 minus 2 times 1. That's 1 minus 2, which is negative 1. So if I go to a graph, I have a point at 0, 1, that's up here, and a point at 1, negative 1. That's down there, and then you just play connect the dots, and you get a nice straight line. And that is the graph of the linear function. So or linear equation. So once you graph a linear equation, you should always get a straight line. If it doesn't come out as a straight line, well, then you probably calculated something wrong, especially if you're using graph paper, because that helps keep your lines nice and straight. Let's do another one. It's not going to look quite like our standard form, even though it is in standard form. Y equals 1. This is in standard form, ax plus by equals c. It's just that our a happens to be 0 and our b is 1. So this still is a linear equation, but we don't have as much information. At least it looks that way. But I'm still going to make a table x and y. Y equals 1 tells me that no matter what, my y is always going to be 1. It doesn't matter what x is, y is 1. X can be anything that we want. So I'm just going to pick a couple values. 0, 2. X is anything. No matter what x is, your y is still 1. When I graph this linear equation, here's 0 and 1. There's 2 and 1. No matter what values I chose for x, when I graph this, I'm going to get a straight horizontal line. Last example for now. Let's graph negative 3x equals 12. This, again, is in standard form. It's just that my b for ax plus by equals c, my b happens to be 0 this time. So if I solve this for x, I see that x is actually equal to negative 4. And that means if I were making a table of points, x is always negative 4, and y can be anything that I want. So let me just pick a couple values. I'll do 0 and 2 again. Really doesn't matter as long as you have 2 points you can graph and get a line. 1, 2, 3, 4. So I have negative 4, 0 is this point right here. And then I have negative 4 and 2 is this point up here. When I connect the dots with these 2 points, I get a straight vertical line. So when you have an equation that's just y equals a number, you get a horizontal line. And when you get x equals a number, it's a vertical line. Now, whenever we work with linear equations, something we talk about an awful lot is slope. So let's define what slope is using a formula. The slope of a line passing through 2 points, I'm going to call them x1 and y1, and x2, y2. And our slope, we usually use m to stand for slope, and that is delta y over delta x. This little triangle here is a capital Greek letter delta, and in mathematics that usually stands for the change. So this is the change in our y values over the change in the x values. Change in my y values is y2 minus y1. Change in x values is x2 minus x1. This, of course, is provided that x2 minus x1 is not 0, because we're not allowed to divide by 0. This will give you the slope of the line. The slope is just the mathematical term for the steepness of the line. The higher the number is for the slope, the steeper the line is. Let's do an example using this formula. So find the slope between the 2 points, negative 4, 1, and 2, negative 2. And we're going to use our new formula. The slope is equal to y2 minus y1 over x2 minus x1. And now we just have to decide which point is x1, y1, and which one's x2, y2. And it really doesn't matter which one we choose. No matter which way you do it, as long as you're consistent in the problem you're working on, you're going to get the same answer. So what I usually do is I just list my first point that's listed as x1, y1, and the second point is x2, y2. Again, it does not matter. You can do it the other way and still get the same answer. So when I plug these in, I get -2 minus 1 over 2 minus -4. Be very careful with your signs. I would suggest that you even write it as minus and negative. Change it to addition later. So when I simplify this, on the top I have -3. On the bottom, this is 2 plus 4, which is 6. And I can simplify my fraction and get -1/2. So having a negative slope just means that if I were to graph the line that goes through these 2 points, the line is going to be going down from left to right. So anytime you have a line that is not horizontal or vertical, you're going to have a slope that is, well, it's going to be positive or it's going to be negative. Now, if you have a horizontal line, you have a slope that's 0. And if you have a vertical line, we say that we have undefined slope. So horizontal line, remember from earlier, we said that those are of the form y equals some number, which I'm going to call k. They have slope 0. And vertical lines, which are of the form x equals a number k, they have undefined slope. An easy way to remember which one's which, think of your slope again as the steepness of the line. If you picture yourself walking along the line, a horizontal line is very, very easy to walk along. You don't really have a slope, you're just staying flat. A vertical line, if you tried to walk up that, it's not going to work. It has undefined slope because you're not even going to be able to walk up that particular graph. It's too steep. So now that we know a little bit about linear equations and lines, and we know about our intercepts from last time, we're ready to learn something called the slope-intercept form of a line. So given a line with slope m, and y-intercept 0, b, the slope-intercept form of the line is y equals mx plus b. I feel like this is one of the most common things for people to remember from previous algebra courses, yet there's still usually issues with trying to graph linear equations and working with linear equations, which is why we are still going over it. So let's get some practice converting into slope-intercept form. One of the benefits of slope-intercept form is that you can see the slope of the line and the y-intercept just by looking at the equation, and then it's super easy to graph because you can put a point on your graph for the y-intercept and use the slope to find another point. So for example, let's look at this linear equation, 2x plus 4y equals 8. And the first thing we're going to do is write in slope-intercept form. So our slope-intercept form again is y equals mx plus b. That means we need to get y by itself on the left side of the equation to put this into slope-intercept form. So let me rewrite my linear equation, 2x plus 4y equals 8. This is in standard form. And I'm going to solve for y. So I'm going to subtract 2x from both sides. And I could have written that right side as 8 minus 2x, but I'm choosing to write it as negative 2x plus 8, just so it's closer to that mx plus b that we're looking for. Now, to get the y completely by itself, I just have to divide everything by 4. So be careful with this. Make sure you are dividing every single thing in the equation by 4, otherwise it's not an equation anymore. So then I just have to simplify this. And I'm going to get y equals a negative 2 over 4. That simplifies to negative 1/2 times my x. And then 8 over 4 is 2. So my slope-intercept form of this linear equation is y equals negative 1/2 x plus 2. So now for part B, we are just going to determine the slope and y-intercept. So we can figure out the slope and the y-intercept without doing any work at all because we already have our equation in slope-intercept form. Y equals mx plus b, and m is the slope, b is the y-coordinate of our y-intercept. So my m in this case is negative 1/2. That's my slope. And my y-intercept is the point 0, 2. Remember, the x-coordinate of your y-intercept is always 0, and your y-coordinate is going to be your b. Last thing we need to do is graph this. So part C was graph. And I'm just going to remind us, our slope was negative 1/2, and our y-intercept was 0, 2. And remember, to graph a linear equation, you only need 2 points. 2 points is enough to make a straight line. We have 1 point very clearly. We have 1 point that is our y-intercept. So the first thing I'm going to do is put my y-intercept on the graph. The way I personally remember how to do that is, remember your y-intercept comes from the b in y equals mx plus b. B is where you begin when you're graphing. So you begin by putting your b on there, and then the m is how you move. So for a slope of negative 1/2, my change in y is 1, and my change in x is 2, but it's negative. So that means I have to go down from left to right. So this is down 1 spot and over 2 spots. So that gives me a point right here that I get from moving from my y-intercept down 1 over 2. Now that we have 2 points, it's enough to connect and make a straight line. I'm going to go ahead and just put a little more on this graph, down 1 over 2, do another moving with my slope. The only reason I'm doing that is because I'm pretty terrible at graphing on a board. So if I have a couple more points, my lines end up a little straighter for me personally. But you only need 2 points in order to graph, at least for linear equations. All right. So now that we've talked about linear equations, it's time to talk about linear functions. Not really that much different, it's just we're going to be using our function notation that we talked about the last time. So definition. Let n and b represent real numbers. With m not equal to 0. Then a function represented by f of x equals mx plus b is a linear function and f of x equals b is a constant function. So the graph of our linear functions and our constant functions both make straight lines. The only difference is your constant function has a slope of 0, so it's going to be a horizontal line, where a linear function is going to be some form of a diagonal line. All right. Let's do an example. Write an equation of the line that passes through the point -1, -4, and has slope 3. Then write the equation using function notation. All right, so if we're going to write an equation of this particular line, we have a choice. Right now we know standard form and we know slope-intercept form. I personally would use slope-intercept form because they gave us the slope. So since I know y equals mx plus b, I do know my m is 3. The problem is I don't know what b is at this point, but we do know a point on the graph. I have the point -1, -4. So I can take that point and plug it in for my x and y values to figure out what b is supposed to be. So when I do that, my y value of the point that I was given was -4, and my x value was -1. So I can solve this for b. -4 equals -3 plus b. Add 3 to the other side, and I get -1 equals b. So that means that the equation is y equals my slope times my x plus my b. So plus a -1, which is the same thing as -1. There is my linear equation, y equals 3x minus 1. And if I'm going to write that in function notation, I just replace the y with f of x. F of x equals 3x minus 1. Another definition for us. A line that is drawn through 2 points on a graph of a curve is called the secant line. So if I have just some curve, something non-linear graphed, and I have 2 points on this graph that I'm going to look at. Let's just say this point here and this point here. If I draw a straight line connecting the 2 points, this line here in green is the secant line between those 2 points. Secant line is very important for calculating something called the average rate of change, which we're going to talk about right now. So if 2 points x1, y1 and x2, y2 are on the curve f of x, then we can write these points as x1 f of x1 and x2 f of x2. If our function is defined on the closed interval x1 to x2, then the average rate of change of our function on the interval x1 to x2 is the slope of the secant line. Containing these 2 points. So what this means, using our slope formula, we have that the average rate of change is equal to f of x2 minus f of x1 over x2 minus x1. Now, this average rate of change is very important for calculus as well. In calculus, you're going to take it one step further than this and get something that's the instantaneous rate of change. But it's important to understand average rate of change before you make that jump into calculus. But it's one step away from calc. So let's do an example where we calculate the average rate of change. So for the function f of x equals x to the third plus 2, determine the average rate of change from x1 equals -3 to x2 equals 0. So to do this, we're just going to use the formula we just saw. Our average rate of change is equal to the slope of the secant line. So I have that my slope is f of x2 minus f of x1 over x2 minus x1. So my x2 was 0, and my x1 is -3. So plugging it into my formula, I have f of 0 minus f of -3, all divided by 0 minus -3. To figure out what f of 0 and f of -3 are, we have to plug those values into our function, like we did when we first learned function notation. So my function was x to the third plus 2. So that means f of 0 is 0 to the third plus 2. And f of -3 is -3 to the third plus 2. And this is all over 0 minus -3, which is 0 plus 3. Now we just have to simplify. 0 to the third plus 2 is 2. -3 to the third is -27. Plus 2 is -25. But I'm subtracting it. So minus a -25, that's plus 25. Over 0 plus 3 is 3. So I get 27 over 3, which is equal to 9. So the average rate of change of that particular function from those two x values is 9. And that's all I have for you for this particular video. In the next video, we're going to talk more about applications of linear equations, and we're going to learn the point-slope form of a line, which I enjoy quite a bit. So I will see you on the next video. If you have any questions, feel free to drop them down below. Or if you're a current student, you may email me or come to my virtual office hours, and we will answer all your questions. I'll see you next time.